often very complex because the world itself is, of course, complex, and a technological innovation is often not taken into account the complexity of how societies work. So what the integration of SSH disciplines in R&I projects, and specifically here for Cluster 4 projects, can do is create a stronger societal impact, in the sense that you can take into account end users who are important for, of course, the use of technology and used for whatever is produced during projects. You have a broader citizen engagement where you know what people actually want. You can actually include also people from the population you want to target into your project itself, and a sort of co-creation attempt. You have more competitiveness because you take into account economic factors, which is also a very important part of SSH integration, and which is of course also important for development of AI, but not only AI, but anything you can think of, any form of technology, any form of kind of applied science. So all these aspects generally are better, create a better and stronger research for Europe. It makes a better Horizon project, and it just creates a better R&I policy in general. I'll show you some examples of SSH integration. I think the best example was during COVID, where you had, on the one hand, the creation of vaccines, but on the other hand, of course, you need to make sure that people not only wanted to take those vaccines, but at the same time also still adhered to public measures during COVID. I think social health sciences really shed light on what factors played a role in there, and also played an important part in actually making sure that we knew beforehand what would be reasons why people wouldn't want the vaccines. For AI, it's very important for ethical reasons, but also cultural and linguistic reasons. I think that the new AI, I've forgotten the name, but from Elon Musk, really shows why it's important that these SSH disciplines are integrated into the development of AI, because else you get AI that's gives actually raw information.
Technology development. So ShareSpace is about embodied social experience in hybrid spaces. We say hybrid spaces if it's real and augmented environment or virtual environment. And what we look at is, or what we want to develop, is the technologies that allow people at remote location to interact together, but this time not just over video as we are doing now, but over a virtual avatar. So what you see here also on the picture is a real person, but around him in a real environment or in a virtual environment with virtual avatar. So it's a group of persons and they start to interact together, doing some common activities. And we were interested in the sensor space, so how we perceive other action and how people react with an avatar. And technology. So we have three fundamental aspects: motion amplification, motion synchronization between people, and then we also develop different level of autonomy of avatars and want to reflect on this. Amplification is basically the idea behind this is when you do a gesture, that the intention of the gesture is in some features in the gesture. So if with AI we can identify the intention of the gesture by analyzing the motion, maybe we can take this feature, amplify it to make it more easy for other people to understand what you want to say or what is the intention of your gesture. Like you want to take a bottle, before you grasp the bottle, we can detect if your gesture, your intention is to give the bottle to someone else or take it for yourself and maybe drink. So maybe we can amplify these features we identify in the motion to make easier for the other people on the other side to read out what is your intention. That's the first concept we have. And here is a cognitive science, is a professor from Hamburg.
Tamam, çok teşekkür ederim, çok sağ olun. Tamam,
Sorry,
tamam.
I'll fix it.
The other concept is synchronization. So in a group, or maybe you notice already when you walk with someone close, someone on the streets, the pace or the frequency of your step is the same or very similar. So you get synchronized to this person. That appear also in groups, and we can show that also this synchronization can be measured. And now the question is, if you have a group with virtual avatar, how to synchronize with virtual avatar and bring these people together to have a synchronized and better connection among the people. That can be measured, and that can be also in a way amplify or make sure. Okay, that means that we have these two concepts, and then we start to work on avatar motions, and we modify the motions of the avatar. So we capture what a person is doing, transfer that to the avatar, and you meet with the virtual avatar of other person, but we may modify this the motion patterns or the motion we measure. So we introduce different level of autonomy of avatar. So a fully controlled avatar is like a little bit in autonomous driving. L1 is fully controlled. So my motion is transferred to the avatar, and in the virtual space we meet all together. Or maybe I change something to amplify some motion to make sure that the connection between the people are ensured. So we speak about semi-autonomous avatars, or we could even imagine to have fully autonomous avatar that participate to some activity. If you do the gym, it's maybe good to have a few companions doing also some gym around you, and you get synchronized with them and can work with them. That's the basic idea. So, as I say, we started with the concept of ethic by design, and try to integrate ethic concepts in the project development at every stages. And we show as much as possible the technology, and we share, let's say, our concern and show the potential of the technology. Also, maybe in predicting development state within 3 to 5 years. Yes, so the main challenge was to establish this collaboration, this relationship, and not just have, let's say, like a top-down, from our point of view, technologies, compliance or guideline to follow. That was, I think, the main things we wanted to reach. But we wanted to see, okay, what's the impact and how should it ideally work within such technology development.
Back to the magic or the magician project. So, the idea with the project, or the challenges with the project, is that, all of us want nice cars, right? So the production should be top notch, and at the same time, this part at the end especially is done by humans, and can be both physical and cognitive demanding for the workers. So the objective is, okay, can we help? So it's not about replacing, but to work together with the human and develop some solution to detect errors and to repair them. And this will be done by developing some modular design for robotic solutions, and make the environment safe and to reduce the physical strain for the workers. And this will be followed by a human-centered approach. So the approach is human-centered, and the use case is basically to put this, the robot that we will take, into Tofaş, which is a car company that are producing the cars in Turkey. So that is the goal, to put it in the factory production line. And some of the requirements, since it will be together with humans, we need to know where the human is, so we need to track the human to not hit, but also we're using the tracking to see or record, okay, how are the workers moving, how are they searching for errors, so to allow the robot to learn from the movement.